Okay, number 51. Number 51 looks like a sinusoidal curve. I mean, it is a sinusoidal curve. We don't know if it's a sine curve or a cosine curve, but really you could rewrite a sine curve as a cosine curve, so that doesn't really matter. I'm also pretty sure it's graphed in radians, but the given scale isn't that useful. I mean, they gave you 3 and 6 instead of pi and 2 pi, but we'll work with it. So we have the derivative graph. And if the derivative is a sine curve or cosine curve, that means the original function had to be a sine curve or a cosine curve. It also means that the second derivative is going to be a sine curve or a cosine curve. So really, we're just going to be looking at what that looks like for like where the relative min and max are and things like that. So let's start with some zeros. So the zeros of the derivative graph are going to be the relative extrema of the original graph, right? So 0 for the derivative is where my relative extrema, the mins and maxes, are for my original function. So I'm going to look at where I'm switching between positive and negative, and that's going to tell me where my original function is switching between increasing and decreasing. So my derivative graph is positive to the left of this blue line, negative in between the two blue lines, then switches back to positive for the next interval, and then switches to negative. So that means that my original graph is going to be increasing in this space. Put this in blue to show we're going to do our original graph in blue. So from negative infinity, well, not negative infinity, just on this leftmost interval, and then again here, and then decreasing on the other two intervals. And I'm going to assume that the original graph has the same amplitude as this graph. I don't know that it does. But we have to assume, we have to put it somewhere. So if I'm switching between increasing and decreasing, that means my curve is going up and then going down. So it's going to have a relative extrema. Put it right there as a max. Then the next one's switching between decreasing and increasing. So we'll have a relative min. And the next one's switching between increasing to decreasing. So we'll have another relative max. And if we assume we would have had another one down here, right? Because the derivative graph was just switching between increasing and or positive and negative. So it would have been negative to the left of this. So it would have been decreasing then increasing. All right. So those are all relative extrema, relative max, relative mins. We also have on our derivative graph extrema. Which means we have inflection points on the original. So there's a relative max here, which means there's going to be an inflection point, probably at the 0. We have a relative min here, which means we're going to have another inflection point, which is probably at the 0, just because the inflection point's in the graph I'm looking at. And then a third inflection point at the third extreme that I see. And so that's enough information to draw my curve. Not going to be able to draw it great with my mouse, but so concave up switches to concave down. Concave down switches to concave up. concave up switches to concave down. And that would be my original curve. Put a blue box around that. And then we'll look at our second derivative. Okay. So, second derivative. It's going to be another sinusoidal curve. We can look at where my derivative is increasing and decreasing, or I can look at the critical numbers. I know that those are going to be zeros. So the extrema of the derivative are going to be zeros of the second derivative. Now, the extrema, we also said were inflection points. So it's very possible that the original graph and the second derivative are the same graph, right? If I started with a sine curve and I took the derivative, I'd get a cosine curve. If I took a derivative of cosine, I'd get a negative sign. So maybe it's the same but reflected. So let's take a look at that. So I really need to get some red points for my second derivative. So the relative extrema are going to be zeros of the second derivative. And let's see if it is going to be the same as the blue curve or if it's going to be reflected. Okay. If my first derivative is increasing, that means my second derivative is positive. If my first derivative is decreasing, it means my second derivative is negative. So for example, figure out where to start. My derivative graph is increasing from the point all the way to the left to that first relative max. So it's increasing from there to there. Okay, on this space, it's increasing on this space. So that means that on this space, my second derivative is positive. Then it's decreasing from here to here. So that means that my second derivative is negative. I could also say that my derivative graph switches from concave up to concave down. Right, it's going to be concave down into this first blue line. The derivative graph is concave down and then switches to concave up. Which means that's an inflection point on the derivative graph, and it's a relative extreme on the second derivative. So if I switch from concave up to concave down, the second derivative is going to go from increasing to decreasing, which would be a relative max. If I switch from concave down to concave up, that means my second derivative is decreasing and then increasing. So I'm going to have a relative min. So it is a reflection of what I was looking at before. And I can draw that. Okay, to go through that again, okay, if I look at the derivative graph, So I'm going to use black and white now. Let's say from here to here on that interval, my derivative graph is decreasing. Put that in red, put that in black because it's a part of the derivative. And then it's concave up, so it's increasing. Did I move my graph too much? Now I'm trying to figure out what's happening. Okay, that's where I want it to be. Okay, so hard to see because there's so much going on right now. But on the black curve, it's decreasing and then increasing. Which is why on the red curve, it's going from negative values to positive values, and there's a 0 there. I can also look at the concave down or concave up. So let me just get a rectangle tool and use that. So in this space right here, my graph is concave. My derivative graph is concave down, which means that its derivative is decreasing. Then on this next rectangle of space, my derivative graph is concave up, which means that the second derivative is increasing. So looking at this space, concave up, increasing, concave down, decreasing. So if my second derivative is switching from decreasing to increasing, it has to be a relative min. And that's how I know it went right there.